The universe has not always been understood as something that had a beginning. For centuries, people believed it had always existed, fixed, eternal, unchanging. We look at the sky and see stars, galaxies, and nebulas that appear to be there since forever. Philosophers like Aristotle imagined a static cosmos. Even scientists like Isaac Newton, centuries later, thought of space as a fixed stage, where objects move but the stage itself remains unchanged. That idea of eternity was comforting. A universe without a beginning required no explanation. But everything changed when science began to observe the universe with more powerful instruments. In the early 20th century, Albert Einstein developed the general theory of relativity, showing that space and time were not separate entities, but a single structure called space-time. That structure could bend, expand, and deform according to the mass of objects. Then something unexpected appeared. When Einstein applied his equations to the entire universe, he realized that space-time could not remain still. It had to either expand or contract. Disturbed by this conclusion, he altered his theory artificially, forcing the universe to remain static. He would later admit that this was the biggest mistake of his career. Even with resistance, evidence began to accumulate. In 1929, astronomer Edwin Hubble observed that all distant galaxies were moving away from each other. The farther they were, the faster they receded. This meant that the universe was expanding. If it is expanding now, it must have been smaller in the past. And the further back we go in time, the more compact and dense it becomes, until reaching an extreme point where all matter and energy were compressed into something infinitely small. That point would later be called a singularity, and the moment of its expansion became known as the Big Bang. But the Big Bang was never understood as a common explosion happening somewhere in space. In reality, the Big Bang did not happen inside space. It created space itself. Space, time, particles, and the forces of nature all were born in that instant. And so came an inevitable question, perhaps the deepest one ever formed by the human mind. If the universe began with the Big Bang, what existed before it? Science usually avoids that question because it contains a logical trap. The word before assumes the existence of time. And if time began with the Big Bang, there could not have been a before. It's like asking what lies south of the South Pole. This reasoning was firmly defended by Stephen Hawking, one of the greatest physicists of all time. Struck by a degenerative disease at the age of 21, Hawking lost the ability to move and speak, but his mind traveled where no other scientist dared. He directly confronted the forbidden question: what really happened at the moment of the Big Bang? And more boldly, what does it even mean to ask what came before? To Hawking, the question was formulated incorrectly. According to him, at the most extreme levels of reality, time does not behave like a line with beginning and end. Near the Big Bang, time behaves like a smooth curve, similar to the surface of the Earth. When you walk south, you eventually reach the South Pole. Beyond that, there is no south, not because something is hidden there, but because the concept itself stops making sense. To Hawking, time works the same way. Near the Big Bang, it does not point backward to a sharp beginning. It curves smoothly until the notion of before disappears. There is no moment before the Big Bang because time itself began there. Asking what existed before is like asking what lies below the lowest possible point. This conclusion is uncomfortable, yet powerful. If time began at the Big Bang, then we do not need to search for an earlier cause. The universe did not need something to push it into existence. It simply emerged according to the laws of physics. But that leads to an even deeper question. If time began with the universe, then how did the universe decide to appear? Was it pure randomness? Was it inevitable? Or is there something beyond time and space that gave rise to all of this? That is the most extreme frontier of modern science. Some scientists argue that the universe could have arisen from a quantum fluctuation, a phenomenon where particles appear and disappear spontaneously in a perfect vacuum. In the subatomic world, the vacuum is not empty. It is a restless field of constant agitation. In such a setting, the universe could be just one of those fluctuations that never return to its previous state. Other physicists believe that our universe could be just one among many, forming a multiverse where new universes are born like bubbles in an invisible cosmic ocean. Each bubble with different laws, different realities, perhaps even different dimensions. If that is true, then the Big Bang may have been just the birth of our particular bubble, but even that idea does not solve the mystery. Because if infinite universes exist, then what created the mechanism capable of producing them? And if time began with our universe, do other universes have their own timelines? Or does something outside of time generate all of them? The answer is still out of reach, and perhaps it will remain so for a long time. Stephen Hawking did not simply claim that there was no before the Big Bang. He went further and attempted to mathematically describe how the universe could have emerged spontaneously. Together with physicist James Hartle, he developed what became known as the no-boundary proposal. The idea was simple and, at the same time, profoundly counterintuitive. The universe could have begun without edges, without borders, without a clearly defined starting point. Just as the surface of the Earth has no edge where it truly begins, the early universe may not have had a strict boundary between time and non-time. There would be no abrupt instant of origin. Instead, there would be a smooth transition where time behaved more like space, and the universe emerged as a natural curvature of physical laws. Hawking used a simple analogy to explain this. Imagine looking at the top of a snow-covered mountain. There is no clear edge where the snow began. It is simply there, gently covering everything. To him, the universe arose in the same way, not with a sudden explosion, but with a gradual transition from a state where time and space were indistinguishable. Before the Big Bang, there were no clocks, no past, only an undefined quantum geometry, out of which the first instant of time emerged. From that point onward, the universe began to evolve, and everything we know unfolded. But while this explanation convinced many physicists, others argued that something was still missing. Because even if time began at the Big Bang, there remains the question: what produced the laws of physics that allowed such an initial transition? Where did those laws come from? Hawking argued that the laws of physics exist on their own and that they are sufficient to create a universe. In interviews, he often declared that there was no need to invoke a creator to light the fuse of existence. According to him, gravity and quantum mechanics combined already allow the spontaneous creation of something from nothing. But that quantum nothing is not truly nothing. It is not absolute emptiness. It is a restless field full of possibilities, where particles constantly appear and vanish. In one of those events, the universe could have appeared as a bubble that never collapsed. However, some scientists disagree with this view. They argue that this quantum nothing is still something. So we still have not answered the fundamental question: why is there something instead of nothing? The answer remains elusive. To some, it may never be found. To others, science might still lack a deeper language, a more unified theory that could explain everything more completely. Many physicists believe that such a theory will arise from combining Einstein's relativity with quantum mechanics, leading to what is called quantum gravity, or in simpler terms, a theory of everything. One of the strongest candidates for that theory is string theory. According to it, everything in the universe, from atoms to galaxies, is not made of point-like particles but of vibrating strings existing in extra dimensions beyond the three we perceive. These strings could exist in multiple parallel realities called branes. In one particular idea, known as the ekpyrotic model, our universe could have originated when two branes collided, releasing a massive amount of energy, what we perceive as the Big Bang. In this scenario, the Big Bang is not the beginning of everything. It is just the result of a cyclical event happening repeatedly in a larger reality. Before our universe, there was another, and before that yet another, an eternal cycle of collisions and rebirths. Another possibility is the so-called Big Bounce. In this theory, the universe before ours expanded, reached a peak and then began contracting. When it reached extreme levels of density, instead of collapsing forever, it bounced, reversing its motion and giving rise to a new universe, ours. If that is true, then the Big Bang was not the beginning but a turning point in a cycle. The universe breathes like a cosmic lung, expanding and contracting endlessly. It is born, grows, dies, and is reborn. No beginning and no end. Only transformation. There are also those who suggest that we live inside a simulation. Scientists and philosophers like Nick Bostrom, and even popular figures like Elon Musk, argue that if it becomes possible in the future to create simulated universes inside computers, then statistically, it is far more likely that we are living inside one of those simulations rather than in the base reality. If that is true, the Big Bang could have been the moment when the simulation was initialized. The before would be the real world outside that simulation. If that sounds absurd, consider that today we already create entire digital universes in video games and simulations with their own internal physics. For any entities inside such worlds, the code is reality. To them, our hands would never exist. Among all these possibilities, one thing becomes clear. The question, what came before the Big Bang, may not have a single answer. Perhaps the universe does not have a linear history as we imagine. Perhaps time is not a line but a web. Perhaps there are multiple timelines, multiple beginnings, multiple universes. Perhaps our emergence was not a one-time act, but one of countless cosmic events happening all the time in dimensions we cannot perceive. Stephen Hawking, despite defending the idea that there was no before, acknowledged that the question itself is fascinating and necessary. Even if there is no definitive answer, the very act of asking pushes us beyond the obvious, beyond daily concerns. To think about what came before time is to step outside the limits of our existence and see reality as something vast and mysterious. Not to find all the answers, but to realize how much is still left to discover. Whatever the true explanation for the origin of the universe may be, the question inevitably leads us to another level of reflection. What does it mean to exist in a universe that had a beginning? If time suddenly emerged, if matter appeared, where there was once nothing, then existence itself is no longer ordinary. Everything we see, touch, and feel is the result of an extremely unlikely event. The chances of a universe like ours existing are close to zero. Even more unlikely is the emergence of life, and even more improbable is that such life would develop. Consciousness, language, memory, and the ability to reflect on its own origin. And yet, here we are, living in a universe that seems to want to be understood. To some scientists, this extreme coincidence is a clue. They believe that the universe appears to be finely tuned, as if programmed to generate life. This idea is called the anthropic principle. If the constants of physics were slightly different, stars would not form. Without stars, no heavy elements. Without heavy elements, no planets. Without planets, no oceans, no DNA, no plants, no animals, no you. The universe seems calibrated, with such absurd precision that any minimal deviation would make life impossible. This has led many to think that there may be many different universes, each with its own set of laws, and only in a few of them life is possible. We exist precisely in one of the rare ones where conditions are just right, not because we were chosen, but because in all the others where life does not exist, there is no one there to ask questions. Other scientists reject that idea and argue that maybe we still do not fully understand why the laws of physics are the way they are. Perhaps at a deeper level there is no randomness. Perhaps there is only one possible way for a universe to exist, and we live in it because there could be no other. Stephen Hawking used to say that science still does not know why the laws are as they are, but he also said that seeking that answer is what makes us human. Even knowing that we may never find all the answers, we continue to ask. That is what sets us apart from every other creature. We do not live only to exist, we live to understand. When we examine the question what existed before the Big Bang, we realize that it may not have just one scientific answer. It also reveals a philosophical and even existential dimension. Because if there was no time before time, if the universe arose spontaneously without the need for a cause, then we are children of a colossal improbability. We are the result of a spark that could easily never have happened. In a way, we are a cosmic accident. But if that is true, then every second of awareness becomes even more precious, because there was no guarantee that we would be here to witness the universe. But what if we are not an accident? What if somehow the universe wanted to be perceived? Physicist John Wheeler suggested that reality might only fully exist when there is a conscious observer to perceive it. In that sense, the universe did not only create us, we are the way through which the universe observes itself. Every time someone looks at the sky and wonders where everything came from, the universe is asking about its own origin. If that is true, then the question, what came before the Big Bang, is not just a scientific curiosity. It is the deepest echo of existence trying to understand itself. Perhaps we will never have absolute certainty. Perhaps science will get closer and uncover new layers of reality. Perhaps we will find evidence of multiple universes or detect signals from civilizations older than ours, holding more advanced answers. Or perhaps the mystery will remain forever, not because the answer is impossible, but because our human mind is not yet capable of grasping something so vast. Stephen Hawking said that maybe we will never find the final answer, but that the important thing is to never stop looking. The past may be hidden behind the veil of time, but the future still lies open ahead of us. If time began with the Big Bang, then everything we know exists within that short interval between beginning and end. Stars are born, shine, and die. Galaxies collide. Planets form and disappear, and one day, even the universe itself may cease to exist. Some theories say that it will continue expanding until galaxies become so distant that no light will be able to travel between them. The universe will slowly fade into cold silence. Others say that gravity may pull everything back again, and the universe will collapse upon itself, returning to a point of infinite density, beginning a new cycle. In that case, perhaps we are living between two beats of a cosmic heart that pulses eternally. And if that is so, perhaps we should stop asking what existed before the Big Bang as if there were only one answer. Perhaps we should ask how many beginnings there have been, how many universes were born and died before ours, how many times reality has ignited and faded away, and more importantly, where exactly are we in that cycle? Are we the first to think this? Or are we just one more among billions who have looked at the stars and asked where everything came from? In the end, perhaps the most honest answer is to accept the mystery as part of the journey. Science can explain much, but not everything. Philosophy can expand reflection, but not conclude it. Perhaps the truth lies beyond words and equations. Perhaps the universe is not just something to be understood, but something to be contemplated. If there was nothing before the Big Bang, then the universe is the first note of a cosmic song still being played. And we are part of that melody.